Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and we are into our session number six of Multicast from scratch. We are already done with the multicast switching. We understand IGMP snooping. We understand IGMP protocol itself, right? Today's session is totally based on multicast routing, and believe me, today's session is going to be more towards philosophy of multicast routing. We are not going to use any much of the technical terms or any term, believe me, because we want to understand the philosophy. We want to be in the shoes of person or of the people who have developed this multicast routing protocol, right? And it is always beneficial to think from the inventor point of view, that what problem he or she could have received at the point of time when he or she was developing this multicast routing. So today's session is going to, please take part in the session, ask as many as questions, right? But today's session is going to be a little bit more on the philosophy side of multicast routing. So only two things are here.
Vishnu,
Yeah, go
Vishnu,
ahead.
sorry to disturb. Are you sharing a screen?
Screen.
Oh my God. If that is the case, then I need. So basically, there are only going to be 2 points. One is when this application is so popular, and when the application is less popular. What is the meaning of so popular and less popular, right? We will get this also during the class. But again, I am repeating that the session is going to be philosophical. Please contribute. Ask as many as questions you want. Please provide your inputs also. Having said that, if you give me next 1 point, maybe 1 hour and 15 minutes, these concepts are going to be with you for a longer period of time, because now you are going to think how this multicast routing protocol uh, would have been created by many people, right? So let's move to the first board, where we are going to discuss multicast routing when the application is popular. So what is the meaning of when the application is popular, right? So here we have source, and source address is suppose 10.10.10.10, our favorite address /24, right? And this source wants to send a multicast stream to 239.1.1.1. And believe me, this stream is actually so popular that it is required in almost every LAN segment. We can say a stream is pretty popular. Suppose we have 200 networks. I couldn't show you all the 200 networks. That is why I'm showing only 4, right? And maybe say in 100 or 120 networks, there is a need for this stream. This stream can be any video song or the message of your CEO. As simple as that, right? So if this stream is popular, we say the application is popular and it is required everywhere. Maybe it could be the case that this blue network doesn't need it. So I am naming these network. This is network number 1. This is network number 2. This is network number 3, which does not need 239.1.1.1. Network number 1 needs it. Network number 2 needs 239.1.1.1. Network number 3 doesn't have any idea about 239.1.1.1 and it doesn't need it, right? Then network number 4, maybe it also need 239.1.1.1, suppose. Good. So what is going to happen here? At the end of the day, if this source is sending this multicast stream is just nothing but just the IP packet, then it is going to create this IP packet with some data of this video song or CEO message, right? The source is going to be 10.10.10.10, no doubt about it. Destination is going to be 239.1.1.1. And of course, this message is going to reach at router number R1, right? So what basically happening here? This message has to go to these router by router to meet these and host. And believe me, when this source creates this message, it only knows that it needs to send the message to 239.1.1.1, but it doesn't know at all where are the receivers. It is sending the message only on 239.1.1.1. Similarly, when you see network side, suppose host A joins this network. Sorry, suppose host A wants interested in 239.1.1.1. It doesn't have any idea where the source of this stream is. This host is just saying through IGMP report messages that it is interesting in 239.1.1. It is showcasing its interest to this router number R2, but this host doesn't know at all where the source of this application is. It doesn't know that 10.10.10.10 is sending it. As simple as that, right? Now, as I'm saying, this application is so popular. So we have Mr. Rahul, and Mr. Rahul is guiding us to deliver this message over these routers. Now we are talking about actual routing. Can somebody see this 239.1.1 as a destination address and can forward it? But the real problem is R1 doesn't know where 239.1.1 is. Maybe it is just a single host. Maybe there are hundred of hosts like this. Very, very interesting. So Rahul is suggesting one thing. Mr. Rahul is saying, I will go and tell every router, whoever is in here, over which this multicast stream is going to go, right, or is going to be forwarded. I will go and tell every router that Mr. Router, please forward this stream to all of your ports. I am naming them. This is R1, this is R2, this is R3, this is R4, maybe this is R5, R6, R7. The problem is we need to deliver this stream, which is going at 239.1.1.1, but nobody knows how many 239.1.1.1 are, how many hosts are there who are interested in 239.1.1.1. So Mr. Rahul is suggesting one simple thing. Whenever it reaches to any router, every router is going to forward this stream on all of the interfaces except the one where it has received it. I think you have heard the same statement in switching also. Because let's say what I'm doing here is I am representing the stream or this IP multicast packets with this red line. It reaches to R1 and I have informed R1, Mr. R1, the stream which you are getting is really popular. Popular means it is needed by everybody, almost everybody. So please forward it on all of your interfaces. So what this guy is going to do, this guy is going to forward it is on this interface towards R2 and on this interface also towards R3. But it is not going to forward it over the same interface because there is no logic. This is just the efficiency mechanism, right? I am not sending the stream back to the same interface where I received the stream. And you all agree, you all should agree with me that there is no point of sending that. But I have informed R1. Again, I am repeating. Application is really, really popular. Send it towards R2 and send it towards R3. The R1 interfaces on which this multicast stream is received are known as incoming interfaces. There is no brain in understanding this term. This 0/1 maybe is my incoming interface. But for this stream, what are the outgoing interfaces? Outgoing interfaces can be more than one. And in this case, if I say this is 0/2 interface, this is 0/3 interface, then basically now my outgoing interfaces are two interfaces, 0/2 and 0/3. This was never the case with unicast routing. Believe me, guys, in unicast routing, if you have a router with multiple interfaces, if you receive a packet, IP packet, you are going to check on this router, Mr. Router, and you are going to ask the routing table that whether you have this destination IP address or not. If you are going to have, it will be showcasing you that whether you need to forward it to 0/2 interface or 0/3 interface. But the packet should be go out either on this one or this one, depending on the routing table. Even in the case of ECMP enabled, the packet should go out only on one interface. That is it. But here there is a slightly change, and Mr. Rahul is explaining. This packet is reached to router number 1, and router number 1 is saying this application is absolutely popular and I need to forward it on all of my interfaces. My incoming interface for this multicast stream is 0/1 and the outgoing interfaces are 0/2 and 0/3, and that is how it is going to replicate this packet two times. It is going to send it over 0/2 and 0/3. Router number 1 done. Interesting, right? As I have already mentioned that some of the hosts in Orange network are interested, they would have sent the IGMP. Some of the hosts in Green network are interested, they would have sent the IGMP. Here also IGMP. IGMP for what? IGMP for traffic 239.1.1.1 or stream 239.1.1.1. Or to know there is a need in my LAN segment regarding 239.1.1. And R2 has got it right. If that is the case, R2 will be forwarding it towards the switch, and now switch understand how to do. If you have enabled IGMP snooping, it is going to work efficiently. Otherwise, it is going to flood it. As simple as that, right? So Mr. Rahul philosophy is working here. Mr. Rahul is saying, if the application is so popular, send it towards everybody. Very, very interesting, right? Now, what is going to happen? The traffic will reach to R3 and R3 now has to decide. R3 will be saying that suppose this 0/1 interface is my incoming interface, definitely I'm not going to forward it back. What it is going to do? It is going to forward it towards R4, towards R6, towards R7. And of course, at R7, somebody has sent the IGMP request. If that is the case, this stream is going to be delivered from R7 to here. As simple as that. Interesting, right? This stream will be reaching to R6 also. The stream will be reaching to R4. From R4, it is going to forward it here. And from R2, it is going to be forwarded here because every router is going to flood it. Interesting. At R5, of course, somebody is asking for it, and that is why it is going to deliver to the switch. But here is the point. R6 never ever got an IGMP report message for 239.1.1.1 from its LAN segment. If that is the case, IGMP is not going to forward it, right? So basically router 6 doesn't need to forward it. Why? Because nobody is asking it. But still, R6 as a router is receiving this stream. And now we are doubting Mr. Rahul's philosophy of flooding. We are saying, Mr. Rahul, what you have suggested us. Switch is also flooding. Now you are saying router should also flood. Then what is the difference? You are making the network less efficient. You are sending message everywhere, right? You have in fact flooded my layer 3 environment. So Mr. Rahul is saying that of course, there is no doubt about it that I am sending the multicast stream towards all the interfaces, except the one on which I have received. But believe me, I will improve it later, right? So now there are two problems here. Problem number one, this router R6 is receiving the multicast stream from R3, right? And R6 doesn't need it, right? Problem number two, and I'm talking about now problems. Unnecessary multicast stream is received on R6 because R6 doesn't know it, right? The second thing, if you see, if you consider this from perspective of router number R2, router number R2 is receiving the stream from R1 as well as R4. These are, guys, the same messages. These are the same video multicast messages or the video song which is sent by source. But R2 is receiving this on 0/1 interface and 0/2 interface. Both the interfaces are, it is carrying the same message. It is actually the wastage of resources. There are two problems with this. And we have informed Mr. Rahul that your philosophy is okay. You are flooding my entire network and this can work. But here are the two problems. R6 is receiving unnecessary stream. And the second problem is Mr. R2 is receiving the messages or the multicast stream over two different interfaces, right? We need to solve it. Very, very interesting, right? And now I would like to take a pause. 15 minutes are there, and I can see there is a hand raised from Mr. Supreet. Mr. Supreet, please ask your question.
Hey Vishnu, thank you. So I have a question related to IGMP itself.
Mhm.
Now, what we have learned previously is that the router sends the query
Yep.
and the host sends a join message saying that I want to join that multicast IP which is there in the query message. Now, can be there a scenario without sending a query message from the router, the host can directly send a join message?
Yeah, definitely. That is what we have discussed about as a unsolicited IGMP report messages, right? We
Yeah,
dis
got it. Yeah,
Yeah,
thank you,
you
Vishnu.
got it. Okay. So anybody else has any question, you can ask, because in the next board, what we are going to do is we are going to solve these two problems. Mr. Rahul has suggested all these things. Mr. Rahul is going to solve this problem. Believe me. And I could see there are two more hand raises. Guys, if the question is on this board, I would request you to see the next two boards, and if there is a question, then we can talk. The topic is not complete till yet. I am just discussing about a general philosophy. So I would say just wait for another 15 minutes, and believe me, if there is a question there, I will definitely come to you. Having said that, let's move to the next board and let's try to solve these two problems. Okay, so here you go. So I think you understand the two problems, right? The problem number one was that this R6 was receiving two streams, one from here and one from here. We need to solve it. Oh, sorry. R6 doesn't have any IGMP query, so it doesn't need to send, but it is receiving the message here, from here also, and from here also. And if we talk about this R2, right? R2 is receiving the message here also and from here also, right? So these are the two problems. R6, problem number one, R6 doesn't need, right? It doesn't need traffic for 239.1.1.1. And problem number two, R2 and R6 are receiving 239.1.1. Message from various interfaces, which is absolutely wastage. Now here we have Mr. Rahul. We have given this problem to Mr. Rahul. Mr. Rahul is developing it, and now he is suggesting the solution. He's saying, let's talk about the problems one by one. Let's talk about R6, right? So he is saying that I agree with you guys that R6 does not want to receive any traffic for 239.1.1. The reason is because no host in its LAN segment is actually interested in receiving traffic from 239.1.1.1, right? So what is going to happen? R6 can inform this router, maybe which is R4, that dude, I am not interested at all in 239.1.1.1. Now what we are talking about? We are talking that two routers, in this case R4 and R6, are talking with each other. If they want to talk to each other, then we need some rules, some standards, right? If I'm talking to you in English language, it is only happening because you understand the rules of English language. I understand the rules of English language. That is why it is making sense to you. As simple as that. Now, if I talk about rules and standards, very simple. If I say R4 and R6 need some rules, it means that Mr. Rahul is talking about a protocol. Protocol is rules and standards. That is it. He is suggesting that R4 and R6 should talk to each other so that R6 can inform R4, I do not need traffic for 239.1.1.1. Absolutely. Very, very interesting. R6 is also informing, maybe this router is say R5, that I am not interested in the traffic. As simple as that, right? So first problem solution is solved. Sorry, first problem, there is a solution with Mr. Rahul, right? Now, the approach is, again, I am repeating, the approach is very simple. This application is so popular, it is needed everywhere. I am flooding it everywhere. And now, if nobody needs, or if somebody doesn't need it, they should inform me, right? Because if something is needed by everybody, I should go and let them give that thing, right? If somebody is not interested, he will inform me. As simple as that. Simple approach, right? That is what, everything is so simple. Believe me, if you understand the philosophy behind it, philosophy is so simple. We are sending the message stream to everybody. Whoever doesn't need it, just inform me. How it is going to inform me? Through a protocol, right? Because we are not discussing about the protocol. That is why I'm not taking the name of it. But now you should understand Mr. Rahul is talking about some protocol. We need to develop it so that these R6 and R4 can talk and R6 can inform R4. I do not need 239.1.1. As simple as that. Now, let's talk about the second problem. Second problem is again going to be very, very interesting, guys. Let's see it, right? So maybe we have here router 2, and let's talk about router 2 is going to receive the messages or this stream from here and from here also, right? How come router 2 will actually manage to say that it want to receive the message over only 0/1 or 0/2? Because both the messages are same. Router 2 knows it, but its computing power is going to be waste if we take the packet on both the interfaces to just come to know that both the interfaces are sending the same message, right? Router 2 has to find at least one interface, right, which it can say I want to receive only on this interface, and then he can say to other guys that I do not want to receive it. Again, if I am informing other router, I'm talking to it, and I'm talking to it, I'm talking about a protocol, I'm talking about a rule. But on what basis R2 is going to decide whether 0/1 interface is better or 0/2 interface is better to receive this? Here, by seeing, you can say that Mr. Vishnu, I can straight away say that the 0/1 interface and 0/2 interface, out of it, 0/1 is better because it is coming at a shorter path. But the other path will be like this, from here to here, from here to here, and here to here, right? So why to consider traffic from 0/2? It is delayed, right? Or it is at a longer path. And I would like to tell you that basically Mr. Rahul is also suggesting the same thing. If a router is carrying multicast stream over two or three interfaces, how it is going to find the best interface to receive the packet or the multicast stream? And that I'm going to explain you on the next board, that how this router is going to say which one is better for me. For example, consider this, right? We have this router number R3 and we have this source as 10.10.10.10. If that is the case, if I presume that a routing protocol is running, for example, OSPF routing protocol, what is going to happen, guys? R1 will be saying that it has a route 10.10.10.0/24. This is the connected route via maybe 0/1 interface. I'm talking about normal routing. If I talk about R2, R2 is going to say I have a OSPF route for 10.10.10.0/24. It is reachable via router number R1, which is my next hop. Although there is going to be route from two different directions, right? But OSPF will take care this on the basis of cost. Maybe the cost here is 5, here is 5, and here is also 5. So for router, if it reaches the source from this direction, it is going to take cost of 10. This direction, it is going to take a cost of 5. And of course, routing is all about intelligent decisions on the basis of cost. If we are talking about a particular protocol, as simple as that. Similarly, if we talk about R3, right? R3 is going to have the OSPF route for 10.10.10.0/24. It is reachable via R1 and not via R2 because R2's path is going to be a little bit longer in terms of cost. Why I'm talking about routing? Because it is important. I'll showcase you. Now, let's talk about the stream. Stream is going to come from R1. I have told R1 that this application is absolutely a rockstar application. Everybody needs it. R1 is going to forward it on this interface as well as this interface, right? And now R3 is receiving the messages, and what eventually R2 is going to do, R2 is going to send this message from here also. And now let's see the condition of Mr. R3. R3 is receiving this message over its 0/1 interface as well as 0/2 interface. What is going to be the message? If I again write, the message is going to be simple, right? It's a simple IP message, right? But with the multicast address, it is going to have the data, the source IP address. Source IP address is going to be 10.10.10.10, the IP address of this host, and the destination is going to be 239.1.1.1, which is the application which is so popular. So here we have 239.1.1.1. Now, this, as you know, we are trying to solve this problem, right? Which interface should be considered best for this router? And router is going to check the source IP address. Believe me, you can program router to do so, right? All the router is programmed to check only the destination IP address and forward the packet on the basis of that, right? But here we are solving entirely different problem. We are solving problem that which interface is best to receive the packet. And we have discussed one thing, one criteria. Whatever the shortest path is, choose it. And believe me, guys, what about this routing table? Routing table always have the shortest path, right? And it will say that 10.10.10.10 source is actually reachable over R1 and not over R2. Why not over R2? Because R1 path is smaller, right? Because R1 path is best. If that is the case, router 3 will say my 0/1 interface is the best interface to receive this multicast stream. 0/2 interface is not the best interface because it is having, if I go via 0/2, I am reaching the source at a higher cost. At what basis this router is deciding At what basis this router is deciding which path is best, right? On the basis of just the source IP address, right? So what is going to happen, guys? Router is going to just see the source IP address and check which interface is best for this IP address, right? By checking its routing table, it will come to know R1 is the best path or 0/1 is going to be the best path. By the way, after some time, you will come to know that this is known as RPF check, the check which I am performing. I am performing the check on the packet receives on these two interfaces 0/1 and 0/2 to know which one interface is best. And to know that, I'm just checking the source IP address and checking the routing table. Routing table saying 0/1, right? If you want to reach to 10.10.10.10, it is reachable over 0/1 because this is the best path I have. It means that, just try to understand, if we are receiving multicast stream on this router number 1 at 0/1 and 0/2 interface, I am going to check the routing table to know what is the source of this packet. The source is having the best path from here or here. I can check through the routing table, right? And I'm checking it. And that is why I'm calling it a RPF check, reverse path forwarding check. I am just checking the path in the reverse to my source to know which is the best path or best interface. And that is why I am going to decide that 0 plus 0/1 interface is actually my best path, or this is the interface which has passed the RPF check. 0/2 interface is nowhere in the routing table, right? And that is why I'm to showcase you. I will be saying that 0/2 is actually failing the RPF check. If that is the case, what is going to happen, guys? R3 will be informing R2, dude, please do not send this. Why? Because I am already receiving it from somewhere else. And again, I'm saying R2 and R3 are talking. R3 is informing R2. I do not need traffic for 239.1.1.1. Simple. So whatever the problem associated with this routing methodology, or basically when the application is so popular, Mr. Rahul has solved all those problems. He is saying the philosophy is going to be very, very simple. I will be sending it everywhere. Whoever not interested, just let me know and I will not be forwarding, right? So now this stream will be not forwarded here, as simple as that. And of course, when this guy says in this port, right, when this blue network says that I am not interested, or basically it hasn't sent any IGMP report messages, R6 will say, okay, I am not interested in this in this stream. Why? Because nobody wants this, right, in my network. So it can inform this guy, maybe this router is R4. It can inform, please stop. I'm not interested in 239.1.1.1. If that is the case, simply this router is not going to forward this traffic here. As simple as that, right? And now suppose, consider this case of R2. Very, very interesting case. R2 has checking that 0/1 and 0/2 out of these interfaces, 0/1 is my RPF interface. Why? Because it has passed the RPF check. Because here my source is pretty clear, right? That it is pretty near to me. It is going to send on 0/2 interface. I do not need traffic from you guys 239.1.1.1, right? If that is the case, this guy is going to send a message to upper guy, means R4 I do not need, and R4 will not be sending this message here. So the philosophy is very, very simple. First, I will flood everywhere. Whoever doesn't need it can inform me. If they can inform me, I will not be sending it. So in what situation a router can say that I do not need the traffic for this multicast stream? Suppose we have two interfaces, and my multicast stream is coming over this interface also and this interface also, right? And then we have another router here, R2, and we have another router here, R3, and then we have LAN segment here, right? So first thing first, router can say to upstream router if the RPF check is failed. Maybe this is 0/1, this is 0/2. Router 1 doesn't want to receive on 0/2. It can send that I am not interested in 239.1.1. First thing first, if RPF check is failing, router can say on that interface, I'm not interested at all in this traffic, right? Now, suppose we have a LAN segment on this R3, right? And the traffic stream we are receiving is 239.1.1.1, and this LAN stream doesn't need it, right? Because nobody has joined this. If that is the case, it is going to send the message, right? It means that R3 knows that it LAN segment doesn't have anybody who wants traffic for 239.1.1. If that is the case, what it is going to do? It is going to inform to R2. It is going to say, R2, Mr. R2, I do not have anybody who is interested in 239.1.1. Do not send me, right? And R2 eventually can say R1, do not send me. And R1 is not going to forward this traffic here because my downstream, so basically my below routers or the routers below me are not interested in my traffic. I am not going to forward it, right? If RPF interface check is falling, I am going to say I do not need it. Although R1 is carrying this traffic, and now try to understand, R1 doesn't need it at all, right? Why? Because it has already sent the 0/2 that I do not need it, and from bottom routers it is getting that I doesn't need 239.1.1. If that is the case, R1 can send to upstream router, right, that I do not need it. And this is how this type of routing work, this type of multicast routing work when the application is so popular. If the application is so popular, we are going to send it to everywhere. Whoever doesn't need it, they will reply me or they will inform me. And they inform me, I will be not forwarding the message towards them. As simple as that, right? Now, the discussion of this application, which is so popular, is over. If you guys have any doubt, please ask the question. Otherwise, we are going to discuss an application which is not so popular at all. Mr. Burak has a question. Mr. Burak, you can ask the question. Please go ahead.
Okay, thank you, Vishnu.
Mhm.
I wonder when the multicast stream starts, maybe some of the clients could not attend from the beginning.
Yeah.
But these clients would like to see the stream from the beginning.
Yeah.
What can they do?
If the stream is gone, the stream is gone, right? It is just like playing the live match, right? For example, you
Yep.
are going to say that 10 to 10:30 a.m. in the morning, Mr. CEO is coming. If somebody has joined 10:15, he is going to see that at 10:15, not the previous one, because those are missed. But it doesn't mean that the CEO cannot say that I will be recording this, I will be uploading it, and then you can see it later also. But if somebody has joined at 10:15, definitely Mr. Brock, he's not going to receive the previous one. Okay?
Yep. Okay.
Perfect. Let's take a question from Mr. Arun. Please, Mr. Arun, ask your question.
Yes, Vishnu. It's about sending. I do not need the stream from R3. Okay.
Mhm.
So is it gonna wait for some time before sending the message?
Yeah,
I mean,
the
like.
Arunji,
Mhm.
the nitty-gritties we are going to discuss. Believe me, there are another 6
Oh,
classes which we are going to discuss only this thing. But today, the philosophy time, that how basically Mr. Rahul or anybody would have thought to come up with these multicast approach. Okay,
okay.
but believe
Okay.
me,
Okay.
I will be discussing those things. Don't worry. How the message is going to be
Thank
created, I will showcasing in the Wireshark, and I will be completely making a network, right, on the EVNG to showcase you how basically these are going to work. Do not worry about the
you. Okay.
messages. We will be seeing them. Okay. Now let's talk about Mr. Rahul ji. Mr. Rahul, please ask your question. Go ahead.
Yeah, hi Vishnu. My question is, what happens in the failure scenario? So let's suppose that the router is receiving the stream from two different source, right?
Mhm.
And one of them fails from where it was working, and
What one of them?
it
What?
has already denied it
Sorry,
from
one
the
of them.
secondary one.
One of them. What?
So
Let's draw it. Let's draw it.
let's
Let's draw the message. Okay. So basically, we have a router which is receiving stream from two different sources. You are saying, right?
yes. So we have
Maybe
already we
maybe
have
two
the RPF enabled, right?
239.1.1.1, right? And then 239 dot maybe 2.2.2. You are saying this one or
No,
this?
no, I'm saying that, like in your scenario,
Mhm.
you were receiving it from two different path, right?
Yeah,
And you have the RPF enabled, due to which you have responded one path that you do not receive it from the secondary path, right?
absolutely. Yeah.
So what happens if a failure occur? Because you have already told the other path that I do not need it from you, right? And there's no way you can ask again if the failure happens because you are receiving it, you're not asking for it.
Interesting question. And that basically, see, we are developing this protocol right now, so nitty-gritties can be discussed. And here, because this is kind of a philosophical question, we are getting this stream from here, we are getting this stream from here, and now I have already told that I do not need 239.1.1.1 from here, right, on 0/2 interface, right? But now this interface is down. This is your question, right? If this interface is down, Mr. Rahul, believe me, the protocol which Mr. Rahul is developing here, he is saying just keep an eye on the routing table. Okay, if routing table gets changed, I need to do the RPF check again. In this case, believe me, 0/1 is down. We have only one interface, and that is going to be my best interface. If that is the case, this router is going to say again, dude, I was wrong. I need this message again. If that is the case, then this guy is going to forward it. So this is not the case that I am just saying that I do not need it, I do not need it, right? Sometimes if somebody has joined it or something has changed, this guys can also say I need it. Mr. Rahul, am I able to clear your doubt?
So what if the interface comes back again, Vishnu? Like, so if it is which is going up and down, in that case,
Again,
again, this
again,
kind of
yeah, again, as I am
ping.
saying that the PIM protocol or the routing protocol, I do not want to take name, routing protocol, whatever is running, right? The multicast routing, it is going to work. It is not going to work at all if we do not have this routing table.
Okay, okay.
Okay. Now,
But
Fine.
Vishnu, see, we were only getting the flood. We were not asking for it. We were getting the flood for the stream.
I agree. I agree. But now Mr. R2 has informed it was getting the flood. There is no doubt about it from everywhere, right? This interface is down, and basically this interface is something where I have said that I do not. This interface is something where I have said 239.1.1.1 is not needed, right? Or maybe if that is the case, I can just. By the way, we are going into the nitty-gritties. There are some timers implemented that my previous message is going to work only for 2 minutes. Suppose, although the timer is 3 minutes, right? If after 2 minutes also this guy is not send it, then this will immediately sending the flooding topic. How come maybe this router on top, right? What we have said on this interface previously that I do not need it, right? R4 is ready to send it. It has stopped for maybe 2 minutes. Why? Because somebody from bottom is saying that I do not need it. If after 2 minutes it doesn't need it, then maybe it can start the flooding because the nature is flooding. You are right, right? So to keep router 4 that it should not send, I need to send the message again and again. And we are going to discuss it. Believe me, we are going into little bit nitty gritties, which we are going to discuss, Mr. Rahul. Okay.
Yeah.
Perfect. Now let's ask Mr. Lias. Mr. Lias, you can ask your question. Please go ahead.
Yeah, so what if it is equal load towards the source? In that case,
Ha. There is the same question asked in the Hindi class also, and I have taken the note of it. I can explain you that, but with my understanding only, right? But not with 100% surety. So I do not have answer for your this question, that if uh, ECMP is enabled on this, then basically what we can see that both the interfaces should be in my both the interfaces are going to pass the RPF check. In that case, what this router is going to do, believe me, I will let you know. But this is a good question. Same question is asked in the Hindi class, but right now I don't have answer with surety. Okay, Mr. Lias?
Okay.
Perfect. Mr. Burak, uh, please ask your question.
Okay, thank you, Vishnu. But the same question is here from me.
Oh,
That
okay.
what happens if the cost of the different paths are equal? What will the RPF check do? It's the same question, I think.
Perfect. I will be going to explain you. Don't worry. Okay. But
Okay, thank
now
you.
let's move to the next board here, where we are going to talk about another approach, and this is again a mind-blowing experience for you, right? Now, the application is not so popular. Suppose, right? We have again the same host, suppose 10.10.10.10/24, and the application is 239.2.2.2. Or maybe 2, right? So many twos. So if that is the case, what is should be the approach? And we have Mr. Rahul again here, and he is guiding us that, okay, for that, what I would say is, maybe out of these four networks, network number one, network number two, network number three, and network number four, out of four network, only one is interested. And this is interested in 239.2.2.2, and maybe only one host is interested. If that is the case, believe me, when this host joined 239.2.2.2, it doesn't have any idea from where this stream will come. Means, what is the source IP address of sender or the source? It doesn't know, right? It just says that I am interested in 239.2.2.2. I'm not sure where the source is. Interesting. Now, let's talk about this source. When it starts sending a message from 10.10.10.10 towards 239.2.2.2, what is going to happen? It is sending at 239.2.2.2, but see, this source doesn't know where are the receivers. It knows that there is a group of receivers which can be identified with 239.2.2.2, but where are those? It doesn't know. Try to understand. Source doesn't know where the receivers are. Receiver doesn't know where the source is, right? And it was the case with the previous example also, right? But now the thing is, my approach is going to be changed. Previously, multicast application was so popular, and I am sending it to everybody. I am flooding it. Whoever do not need it, doesn't need it, just send me that you do not need it. That is the philosophy I was using here. What I am going to do, I will be sending this multicast stream to whoever host or network which is interested in this multicast stream. I'm not going to flood, right? The approach is different here. Previously, I'm again repeating, I was flooding everywhere, and the networks or the host are going to say, or the router are going to say, no, 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 we do not need it. Do not send towards me. Here, I am sending to only those who need it. Why? Because out of these four network, only one network is in. There is no point of flooding it to every network at the first place. So the approach is totally different. Mr. Rahul this time is saying, if the application is not so popular, send multicast stream wherever it is needed. As simple as that. But here is my problem. Who is going to send? Source doesn't know where is 239.2.2.2. It can be in this network, it can be anywhere, right? And this guy doesn't know where 10.10.10 is, although it can inform. Suppose this is my router number 1, this is my router number 2. It can inform the nearest router through IGMP unsolicited message, which is also known as IGMP report messages, right? And it can inform the R2. It can inform the R2, I am interested in 239.2.2.2, but R2 doesn't know who will be sending 239.2.2.2. This is a problem. Source is going to send this message. R1 knows that there is a source connected with me, which is sending the message to our 239.2.2.2, but I am not sure who is interested in that. It's a big problem, guys, right? Mr. Rahul has just given one statement: send multicast stream to needed places. And now we are asking lot of question to Mr. Rahul. Mr. Rahul, you cannot do that because source doesn't know the where 239.222 is, and the receiver do not know where 10 dot where who is the sender for 239.222, right? See, if this is the philosophy, this philosophy is going to be fail at R2. R2 know that it needs multicast stream, but from where it is going to get it? R1 know that there is a source connected, but I cannot flood it because this application is not that popular. If I cannot flood it, nobody has sent me the request also. What to do? Because R2 doesn't know where actually the source is, where R1 is, or who the hell R1 is, right? So we have pointed out several questions on Mr. Rahul's approach or philosophy that Mr. Rahul, this is not going to work. And Mr. Rahul is pretty calm and composed. He's saying, no, I will make it work. You are absolutely right. Then this approach, it is not going to work, but I will suggest something which is going to be very, very interesting. And that very, very interesting thing is going to be discussed in the next board, right? Or maybe let's discuss it in this board only, right? So what Mr. Rahul is suggesting, the solution of this problem. Okay, let me clean the board. And I believe that you guys understand that what is the problem is. The problem is Mr. Rahul is saying send multicast stream to only needed folks. And the network which needs it is the orange network 239.1.1.1. It has informed this router, this is R1 and this is R2, that I am interested in 239.1.1. This stream, this router is getting is this one, which is having 10.10.10.10, and the destination is 239.1.1.1, right? Now, Mr. Rahul is suggesting one thing, that I will make one router which is going to be a superhero router, you can say. Interesting. We can also call it as a centralized router. And suppose that router I have chosen is this R1, and R1 has one interface, which is a loopback interface. Suppose this interface is 1.1.1, right? And Mr. Rahul is saying that I will inform every router in this network, for example, R3, R4, R5, R6, and R7. I will go to everybody and I will teach him that there is a superhero router which is 1.1.1. What the superhero does, believe me, I'm going to explain you. I am going to R5 also. I will be explaining it. Mister, there is 1.1.1.1, right? Here also I will be saying 1.1.1.1 is there. This is a superhero router. Similarly here also 1.1.1. Every router I am going to inform there is one interesting router. Very, very important. Everywhere I have informed. I have informed R1 also that Mr. R1, you are very, very important router. You are superhero. But now the question is, Mr. Rahul, why are you doing this? Right? Mr. Rahul is saying, I am doing this because this superhero router, which is and presume that OSPF routing protocol is running. So if I say 1.1.1.1, then everybody is having route for 1.1.1.1, right? Of course, right? This is a loopback protocol. You can advertise it in the routing table and everybody should understand 1.1.1 is there. The route is there. And now on top of it, I am just explaining one more thing that this guy is superhero or a centralized router. Now we are asking Mr. Rahul what this centralized router does. And you are saying to every router that this centralized router 1.1.1.1 is actually supposed to have all multicast stream. Really, really interesting. Okay, now the problem can be solved. Rahul just said one thing, and I think maybe 20, 30, or 40% of audience, whoever is here, they could have figured out that where I am going with respect to this. So now just try to understand. Orange network has shown interest in 239.1.1. Doesn't matter if one host, several hosts, doesn't matter. If this guy are to receive single membership report, it is going to deliver the traffic, right? But now R2 has information that, okay, somebody in my LAN network is asking for 239.1.1.1, right? And what I would do, I would send, right? And I know that it might be the case that the stream for 239.1.1.1 is actually with 1.1.1. It might happen, right? Why? Because this is a superhero router for me. It might have stream for everybody. So I do not know whether it has the stream or not, but what I can do is I can ask, I can send a request, I can talk. R2 can talk towards R1. Here they are directly connected, but they basically can say that Mr. R2 is going to say, I am interested in 239.1.1. But where this request should go? This request should go towards superhero router. As simple as that, right? Very, very interesting. And now R1 is actually receiving it previously from here to source, right? And now R1 is receiving, oh, there is somebody who is interested in 239.1.1.1. Now I need to forward this traffic from here to here and from here to here. As simple as that. Now suppose after some time, this green host, somebody is also interested in 239. Guys, do not get confused. Here I'm taking the example with 239.1.1.1, right? You can take the example with anything, right? So here also, this guy is interested in 239.1.1.1, which is the application which is not so popular, but now this guy wants to receive it. If that is the case, what is going to happen? This will be sending the IGMP report message. R5, R6 understand that there is somebody who is actually interested in 239.1.1.1. If that is the case, R6 also know the presence of one superhero router which can have this multicast stream. If that is the case, it can straight away ask. It can straight away ask from here to here. I am interested in 239.1.1. If that is the case, this stream can flow from here to here and eventually can be delivered to here. See the philosophy. To begin with, nobody knows where the source is. Source doesn't know where the destinations are, right? because these are the group of destinations. Mr. Rahul intelligently suggesting one router should be having this superpower and it should be informed to everybody that this is the superhero and everybody is going to send requests towards it. And if that superhero is receiving the message from the source, believe me, it is going to deliver it. So what is the approach here? The approach here is simple. I will be delivering to my message, means if I'm a source, I will be delivering my message towards the superhero router. And superhero router will be getting the request to receive this stream from so many places. If that is the case, superhero router will be delivering these messages. Similarly, just try to understand. Suppose now this orange, or sorry, this yellow router yellow network is again want to receive, it is going to send the IGMP join. R5 will see, okay, somebody is interested in 239.1.1.1. If that is the case, it is going to send the request. I want to attend the 239 to 239.1.1.1 message. But where it is going to send? It is going to send this message towards 1.1.1.1, which in its routing table, right? Routing table can say that you can go towards R3, right? Of course, it is going to send the request towards R3. R3 will be going to send the request toward again 1.1.1.1 because somebody at the bottom has requested traffic for 239.111. R3 will be saying, I need traffic for 239.111. Why? Because somebody downstairs, right? Somebody downstream, sorry, wants to receive 239.111. If that is the case, R1 will see, okay, there is another one who wants to receive it. If that is the case, it can deliver it towards R3. R3 will be forwarding it here, and then basically it will be delivered here. Approach, once again, I am saying absolutely different. Previously, I was flooding. Here, I am sending to those who are interested in. I have explained the same thing in the next board, right? When the application is so popular, here in this case with the shortest, suppose this guy is sending here and this guy is the centralized router or the superhero router, right? If from here somebody has joined it, then it needs a stream. It is going to say again, I need traffic for 239.1.1.1, which is here, right? It will be forwarding the request. And everybody, this superhero, maybe 1.1.1, it is understood by this guy also, is this guy also, are to know that my superhero is 1111. If some request is going to come, I will be forwarding this request here. And I will be say, okay, I have 239.1.1. And that is how it is going to forward this. As simple as that. Right? So the important piece in this routing or multicast routing philosophy is this centralized router or this superhero router. And by the way, guys, believe me, if you have heard about Rendezvous point, RP in multicast, this is the guy. But try to understand the logic why we are introducing it. We didn't need it. We didn't feel the need of this rendezvous point or RP when we were discussing a case when the application is not that when the application is so popular, right? Oh, sorry for this. I think I need to say when application is not so popular here, right? But in case of when the application was so popular, we were just flooding. If nobody needs, just inform me. Here, I'm sending to the guys who needs it, who actually needs it. So in the first philosophy where I was flooding, I do not need rendezvous point because I was everywhere flooding. But here in this case, we need rendezvous point because source and destinations doesn't know each other. We need to have a common point where to which we can trust that this guy might be having my multicast stream. As simple as that, right? So basically, two different approaches, guys, right? And now I would move to the next board, which is going to be the last board, and I would like to finish here. The first approach which we talked about, guys, is known as dense mode. Why dense? Because it is believed that application is so popular that it is required everywhere. It is densely required, you can say. And as I mentioned, that we need protocols to run because R1 and R2 need to share messages with each other. This protocol is known as protocol independent multicast. But why this strange name? Why can't we say multicast routing? Why it is protocol independent multicast? Try to understand. When we have this router which is having two different interfaces 0/1, 0/2, and if I receive two multicast stream, I need to select one, which is the best interface by doing the RPF check. And on what basis we could do the RPF check? You all know for RPF check, we need to check the routing table. And this protocol says, doesn't matter where this routing protocol come. It can come to OSPF routing protocol. It can come from RIP routing protocol. It can come from BGP. It can come from EIGRP. Doesn't matter at all. I just need a routing protocol, irrespective of the protocol. Sorry, I just need a routing table, irrespective of the routing protocol. Even if you are going to give me static route, I can check the routing table to know what is going to be my RPF interface, this one or this one. It means I am not dependent on protocols, and that is why this is known as PIM, protocol independent multicast dense mode. The second approach, where we discussed about that the application is not so popular, it means it's sparse. Very few guys are interested in that, right? We call that approach is PIM sparse mode. And in sparse mode, we have a specific problem. We are dealing with a situation, whoever needs, I'm going to deliver it. And that is why I'm going to need a rendezvous point. I will be sending the message to a rendezvous point, and rendezvous point is going to deliver it to. And every other router is going to ask to this rendezvous point. And here I would like to explain this one more thing, because people get sometimes confused. Suppose I have this router R1 here, I have another router R2, and with this router I am connecting R3, say R4, and maybe say R5. Here this could be R6, and we have now some networks. Here we have network number 1. Here we have network number say 2. Here we have say network number 3. I am running the routing protocol which is known as, or basically I am running a scenario where the multicast application is not so popular. Okay. If that is the case, what is going to happen? Suppose my source is connected here. This source is sending the message towards 239.1.1.1. It is not necessary, guys, that the source needs to be connected to the centralized or superhero router. No, your superhero router can be this one, which is say 2.2.2. And now I need to inform everybody R5 that the superhero router is 2.2.2.2. Here also 2.2.2.2. How I'm going to do it is totally different thing. Mr. Rahul is here to suggest the solution. How you are going to implement it, it is your problem. Believe me, there is a protocol which only does this work, that if we have this centralized router, how I'm going to inform everybody that this is centralized router. R1 also knows that 2.2.2 is the centralized router or the superhero router. What is going to happen? The stream, let me define the stream with again the green band. The stream will come from here to here. Now, router 1 knows that there is a source connected. Why? Because it is sending the packet to its right. And router 1 also understands that 2.2.2.2 is actually the superhero router, right? It doesn't know where to send it. So first thing first, it is going to send it towards the RP. or basically your centralized router. What is going to happen, guys? If somebody is interested, suppose R5 is interested in it, right? What it is going to do? It is going to send the request that I am interested in 239.1.1. If that is the case, this multicast stream is going to be delivered here. But the important point is R5 should know where to send this request to, and it knows already that my superhero router is 22222, right? Similarly, if R6 wants to receive the messages from 239.1.1, right? Or it is listening at 239.1.1, it is going to inform R6, I want to know that, right? I am interested in it. It is going to send the request, I am interested in 239.1.1.1. R7 or R3 is eventually requesting towards R2 because everybody knows that superhero router is 222, and that is why they are sending this request towards 22222, right? If that is the case, R2 will receive this request and it will be forwarding this message like this. As simple as that. Now, this is what I wanted to cover. Now, I am all open for your questions. Mr. Burak, please do ask your question.
Okay, thank you, Vishnu. There is also another protocol which is sparse dense mode. Will we talk about it also?
Yeah, maybe once we are done with the PIM dense and sparse mode, we can talk about a little bit about that too, because it is going to have best of both worlds. Okay.
Okay,
Yeah.
okay. My second question is how the superhero router, which is RP, selected between the all routers?
Believe me, I am going to discuss it. There is a complete protocol on that. There is going to be,
I see.
I think, 15 to 30 minutes discussion on this topic only. Okay.
Okay, my last question is what happens if the superhero router is out of order? Is it possible to make it redundant?
Absolutely. And this is the more efficiency you are going to bring in your multicast network. In case of sparse mode, if rendezvous point is gone, then basically everything is gone, right? So you should have rendezvous point in a redundant manner. We can have a look at that point too also, right? But the whole sole point of today's session, Mr. Burak and everybody, is that we should understand the philosophy behind that what we are doing, right? Basic nitty-gritties or the advanced thing, definitely we can go through. Those are going to make sense if we understand the philosophy or the why behind things. Okay. Now,
I see.
Now let's go towards
Okay.
Mr. Supreet. You are welcome. Supreet, okay, you raised a hand, right?
Yeah. So I raised a hand, but I had a similar questions with Burak, so I lowered my hand.
Okay.
Thanks, Burak, for asking the same questions.
Perfect. Now there is a question from Mr. Naveen KNJD. Naveen ji, please ask your question. Please go ahead.
Yeah. So we are making this rendezvous point centrally so that we will receive that whichever the LAN segments needs that are interested in that particular video streaming, so they can connect that video streams from the rendezvous point.
Yeah,
so
because
would there be
yeah. You are absolutely right.
So would there be any kind? Yeah, Vishnu. So like would there be in case the rendezvous point goes down, so would there be any election or would there any other router will get selected as a rendezvous point, or how it is?
Yeah, that is what I'm saying, that we are going to discuss these nitty-gritties, that if rendezvous point goes down, whether we need to have another rendezvous point, right? And believe me, we can define more than one rendezvous point to make our network, multicast network, more redundant. Okay. Perfect. Now, anybody else? Another question? Anything else? Okay, perfect. So what I'm going to do is, guys, see you tomorrow at the same time. I'm going to stop the recording, and we can meet again tomorrow. Having said that, bye for now. See you tomorrow.